Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance. And today we are going to be discussing isotopes, how to identify the number of protons, neutrons, and electrons in a given isotope. So, isotopes are written pretty standardly in this fashion right here, where you have a number at the top, a number underneath, and then the element's name. So this gives us all the information we will need in order to identify the number of protons, neutrons, and electrons in this species. So this particular isotope is called sodium-19. Na stands for sodium. And the 19 is derived by the number up top. So when we're determining the number of protons in sodium, sodium always has a constant number of protons. The number of protons dictates which element is being involved in the species. And the number of protons is given at the bottom, which is 11. So we're going to say that P is equal to 11. From that same number, we can determine the number of electrons. As with any non-ion, the electrons will equal the protons. So E minus is equal to 11. If this particular isotope, for whatever reason, had a positive charge on it, as sodium generally will carry a positive charge, which means that it has lost some electrons, then the number of electrons would change and be proportionate to the charge on sodium. So the only variable in isotopes is the number of neutrons. And determining the number of neutrons, all you have to do is take the number at the top, in this case 19, and subtract it from the number underneath, which is 11. That's the number of protons. The number 19 is indicating how many particles are in the nucleus. There are a total of 19 particles in the nucleus, 11 of which are protons. So the only thing left would be neutrons, and in this case, that means that neutrons equal 8, because there are 19 total particles, 11 protons, and therefore the remainder is 8, and that can only be neutrons. Our next isotope is sodium. In this case, it's sodium-21. So from here, we can easily write the protons and electrons. Protons are equal to 11 because the number of protons is indicative of the element that's being referred to. And the number of electrons is equal to the number of protons when we are not referring to an ion. So the only variable here are the number of neutrons, which in this case would be 21 minus 11, which gives us 10. So there are 10 neutrons in sodium-21. Let's do another example. In this case, it's oxygen-18. Periodically, you will see an isotope written in this fashion, where all they include is the total number of particles in the nucleus. They do not include the number of protons underneath. So, in this case, you would have to look at your periodic table, and from your periodic table, you can determine that there are 8 protons in an oxygen atom. Remember, the number of protons is directly linked to the species of element that you're referring to. So only oxygen can have 8 protons. If it has any more or any less, it's a different element. So in this case, oxygen is 8, and because this is not an ion, we can also write electrons as equaling 8. Now we just need to find the neutrons. So we take 18 and you minus, which is the total at the top, and you minus the number of protons, which is 8, and you get 10. So 10 neutrons. The third and final way for someone to write an isotope is to include the name of the element and its isotope signifier. So in this case, it's carbon-12. Well, with carbon-12, we know that we're dealing with carbon, obviously. But we're not given the number of protons in carbon. So again, we would have to refer to our periodic table of elements. And once you've referred to it, you'll find that the number of protons in a carbon atom is always 6. And because this is not an ion, we also find that the number of electrons will be 6, because electrons are equal to protons when we're talking about non-ions. Finally, we can determine our number of neutrons. And all we have to do to determine that is take that carbon-12 that we're given and subtract the number of protons, which in this case gives us 6. So carbon-12 has 6 neutrons. And that's all there is to identifying the subatomic species in isotopes. Thank you.